Today, not a lot of sections, but some fun sections. How do we simplify that? Synthetic division would be awesome, but we're going to use long division because we're going to get more complicated in the denominator than just this. So x minus 1 goes on the outside. X cubed plus 3x squared minus 4x plus 5 goes on the inside. What times x minus 1 is x cubed? What times x is x cubed? X squared. And it's x cubed minus x squared. On the bottom row, you change your signs and then add your columns. Add your columns, so you get 4x squared. Then you drop the next one, minus 4x. What times x is 4x squared? 4x. So plus 4x. So if we distribute, we get 4x squared minus 4x. Change your signs in the bottom row, and then you add. You get 0 plus 5. What times x is 0? 0, so you can't do anything. And so you get a remainder of 5 over x minus 1. Okay? That is long division. Okay, you kind of remember a little bit about that, okay, from your classes. Well, to do some of these, we have to do some long division. Now, I'm going to stop right there for a second, okay? Okay, I'm going to stop right here for a second and leave this. And if you want to see this, watch the video. If you want all these written on your note card, you can write all these on your note card. These are all of our integrations. Okay, these are all of our integrations. The integral of du is u plus c. 1 over u is ln of u, and so on. These are all 20 of our integrations, basically, where these three are really important. I don't think we're going to hardly touch these at all. Very, very seldom we do, but we do a little bit because Kendra just had a little earlier, or maybe it was Jesse, had the secant of 2x, tangent of 2x, and that integrates to the secant of 2x plus c, with a 1/2 in front, and so on. But here are all our integrations, okay? So you watch the video if you want any of them written down, okay? The three main ones that you need to have written down for today are those three. So make sure these three are written down. Because you think, well, you have them over there. What happens today is, if there's a number there, then it makes it a little bit harder. Okay. Number 3 we won't use as much, but I think it does pop somewhere in on some of the problems, so that's why I have it down. It's basically 1 and 2 are the two most important ones. That's ones we hit most often. Number 3 we hardly ever hit, but if there's a number in front, then yeah, it's nice to have that one written down somewhere. It would be awesome if you could use your note card on the AP Calc test. It would be, but no such luck. So these are some of them that you have to kind of know. And we'll get practice come March. Will be filled with I forget what they call it, diagnostics. Yeah. March. So we'll have all kinds of diagnostics, practice diagnostics and graded diagnostics and all that. So, and then next year, everything goes online with this. So that'll be really interesting. So I might have to go to AP training this summer just to figure that out, because it's mandatory online next year for taking AP tests. Okay, are we good? Everybody got this written down? Okay. So a problem like this, you would say, well, this is u, but its du doesn't have anything to do with this. And then this is not a trig one, because it doesn't fit any of those square roots or this square. So when you see something that you can't do anything else with, when you get stuck and you can't do anything else with it, you got to think, well, long division. Okay, so let's do long division. The numerator is on the inside. Remember, when you do long division, you got to put in placeholders. So it's x cubed plus 0x squared plus 0x minus 1. On the outside is x plus 2. What times x is x cubed? X squared. And if you distribute, you get x cubed plus 2x squared. Change the signs of the bottom row and then add. Negative 2x squared plus 0x. What times x is negative 2x squared? Negative 2x. You get negative 2x squared minus 4x. Change the signs on the bottom row and then add. You get 4x minus 1. What times x is 4x minus 1? 4. And you get 4x plus 8. Change the signs on the bottom row and you get negative 9. So then it's minus 9 over x plus 2. So that's what we're going to integrate. We're going to integrate x squared minus 2x plus 4 minus 9 over x plus 2. Well, when you integrate x squared, it's just simply 1/3 x cubed. That's easy, right? When you integrate negative 2x, that's easy. It's x squared. When you integrate 4, that's easy. 4x. When you integrate this, not so easy. Okay. Well, if we have this in the denominator, it's like the integral of negative 9 times 1 over x plus 2, or negative 9 times the integral of 1 over x plus 2. What's the integral of 1 over x plus 2? ln of x plus 2 with a negative 9 in front of it. So the last part is minus 9 ln of the absolute value of x plus 2, absolute value plus c. So you got to find this on that list. Excuse me. So it would be this one. Okay? That's the long division. Looking at this one. If we take the derivative of this, it's not going to be this down here. If we take the derivative of this down here, it's not going to end up to be anything like this. So we're just stuck. And when we're stuck, long division. Okay? When we're stuck, long division. So we go x plus 3, and then 3x plus 4. What times x is 3x? 3. And then we get 3x plus 9. Change the signs in the bottom row and then add. You get negative 5. So it's minus 5 over x plus 3. What's the integral of 3? So it's 3x minus 5, the natural log of x plus 3. Are we good with that? When we see this, we think, okay, not long division. So I'm thinking it's going to be some sort of a tangent or something like that. Okay, tangent, sine, whatever. Well, since there's no square root on the bottom, thinking tangent. But this looks funny. Well, what we have to do here is complete the square. Okay, complete the square. So x squared plus 10x plus blank plus 41 minus blank. What's half of 10? 5. 5 squared is 25. So we add a 25 and we subtract a 25. So this is x plus 5 squared. What's 41 minus 25? Plus 16. So it's 16 plus x plus 5 squared and 1 over that. Okay? So our tangent one, tangent that you just wrote down is du over a, I don't know. A squared plus u squared. And that's it, right? So our du, the first derivative of x is just 1, right? So our du is taken care of. So a squared is 4 squared plus x plus 5 squared du. So this is the tangent of, what did it say, over what? U over a? Yeah. Tangent, inverse tangent of u over a. So u is this, a is this. So it's x plus 5 over 4. Ooh. And it's 1 over a in front. Yeah. See, I forget that formula because I don't use it that often. So it should be 1 over a, x plus 5 over 4. So it should be this one. Okay. This one. Since it has a square root, I'm thinking sine. All right, complete the square on this one. Ew. So negative x squared minus 6x plus blank plus 40 minus blank. Well, out of this part, I have to factor out a negative 1. What's half of 6? 3. 3 squared is? 9 is here. What's negative 1 times 9? Negative 9. So really, we added a negative 9 here. So we're going to subtract a negative 9 here, which means we add 9. So it's negative 1 times x plus 3 squared plus 49. We good? Everybody follow me. Switchy order, it's 49 minus x plus 3 squared. all under the square root with a 1 and a dx. Okay? So it's the sine of u over a, right? On your note card, inverse sine of u over a, where this is a squared. So a would be 7, u would be x plus 3, and it's 1 over a in front, so 1/7. There's no 1 over a, so we don't have to worry about that. So then it should be this one. Okay, best of luck to you today.